Hi, I'm Rusty Tanton with my co-manager host, Bresden O'Malley. This is The One-on-One, a podcast for software engineers. Our guest today is Christian Boylston, a machine learning engineer.
Awesome. It's good to be back, Rusty. Christian is a founding engineer at a startup company where he leads machine learning and infrastructure development. He's leveraging his expertise in AI and theory gained from his studies at Georgia Tech. Previously, we met Christian as he served as a machine learning engineer at Loyal, where he was honing his skills in deep learning and machine learning. Outside of work, Christian is an avid movie enthusiast, particularly passionate about the surreal works of David Lynch, which we find ourselves discussing kind of regularly. But without further ado, welcome, Christian.
Hello. Thanks for having me.
Well, we are thrilled to have you here. I know some of the stuff we've been talking about offline before we started recording. Obviously with your interest in machine learning, one question that kind of is a formative, kind of captures everything we want to talk about is, should everyone be learning AI? You want to talk about that a little bit?
Yeah. I feel like I get that a lot. It's a very loaded question because I don't want to say no, but I also don't want to say yes. Because I feel like there's sort of I guess there's sort of like two ways you could look at it, right? Where it's like, should you be looking at AI because that's like the career path, that the only viable one you can go down as a software engineer? Or should you be looking at it as just like tools that you can use, right? And I feel like those are like pretty different perspectives, right?
Yeah.
Like if someone asked me, should everyone become a machine learning engineer? The answer would be like a pretty emphatic, like, no, don't. It's probably not worth all the extra effort versus like, using some of the tools that are available to you currently. Like, I think most everyone I know that's a software engineer is like, they've got like VS Code here and they got ChatGPT right here, or Claude. I use Claude a lot too these days. But and I think if you're not doing that, it's definitely like it can be detrimental to just ignore it. Like, I know a lot of people that I worked with were like, I'm not going to use it. Like, it just makes you dumber. And like, they have a point if you're just kind of copying, pasting everything in there. But I think it is really important to use what's available to you. There's plenty of times where, like today, I was setting up a bunch of like Terraform infrastructure to deploy like a HPC cluster. I don't know a lot about like Slurm or Terraform or a lot of the deployment stuff, but like I would just ask ChatGPT, I'm like, am I saving these variables in a reasonable way? Like, is this a smart way to like be storing these? And it was like, no, it absolutely isn't. And then gave me an answer that was a bit more constructive about how I should do it. And I think getting those really precise answers about like software engineering questions that you have, like having that sounding board, is extremely helpful. It's hard to just say that it's just like a better Stack Overflow. Like, I feel like it really does. There is something more to it that I've at least experienced.
Yeah.
So that's like the side of it on the tool side where I think people should do that. And we can dive into the machine learning engineer side if people should do that, if you guys are interested in that part.
Yeah, I would love to. I want to ask one follow-up right before we do that.
Yeah, let's do it.
I heard the same arguments being made about Google Maps, for example. So if you're using GPS navigation, you're using Google Maps navigation, it's making you dumber. I will say I've had to teach my kids intentionally to be able to read maps when we're out places because I could see that potentially happening. I guess the question that comes out of that is, how can someone be intentional about not dumbing themselves down as they're using these tools?
I feel like I struggle to not, go on autopilot and let it do a lot for me, because a lot of times you can kind of, let it spit out a bunch of stuff to like get you like to where you want to go pretty quickly. But like I had one recently where for about a month I had to do like front end development. And I'd never done HTML or CSS, JavaScript, React, anything. So I just kind of like dove in, was just like consuming that for like a month straight. And I was like recreating my personal website, and I was just having like Claude just write the page, write a component for this, like do all that stuff. And it looked pretty good. But then it got to the point where I had to like fix this one thing. And I had to like go back and refigure out everything that it did to figure out what was going on to know the one thing that I needed to change, right? So I think like the thing that I try to do now is like whenever I have it do something and like write some code for me, I will read the code myself and I will ask it to explain the parts to me that I don't understand and make sure that like before I copy and paste, I know every single thing that's going on there. I've clarified what's happening. To be fair, sometimes it is okay to just like if you think you can just like you're not going to use this script again, you just need it to do something like really quick and easy. Just have it like spit something out, and if it works, it works. And maybe don't worry about it. But if you think it's anything of importance that you'll have to do again, like I would suggest just reading over it and making sure you understand everything that's coming out.
Yeah, that makes sense.
It does. I mean, technically, you can also ask it and say, "What does every component here do?"
Oh yeah, that's what I do. I'm like, there was one that I was doing where I was just like ad nauseum, like I don't understand. Please re-explain this to me again. And then I'm like, pretend I don't have a frontal lobe. Please explain this.
Explain this to me as if I was an idiot. ChatGPT comes back. You are an idiot. Yeah. Is it fair to say AI is always machine learning, but machine learning isn't always AI?
I feel like that's a tough one because I feel like at some point it used to be like reversed a little bit where, so back in the day, AI used to be like this really broad topic, right? Like anything about the study of like human intelligence or reproducing human intelligence in an artificial way fell under the blanket of AI. So it sort of all started back in 1955 or 56, I believe. It was the Dartmouth conference, and a group of scientists across all disciplines came together, and they were going to solve AI in like a summer with the hubris of 1955.
Of course they were. Yeah.
But even then, it was like the expectation was that this would sort of be a cross-disciplinary effort where you would have, neurobiologists, psychologists, computer scientists, people from like all different kinds of areas, and they would collaborate together to recreate the concept of intelligence. That sort of started to change like over time. Like as we started trying to find like applications for these things, there was a time in like the 1980s where we had what were called like expert systems. I don't know if anyone who's like listening would remember that, but those are sort of like the old school, like rigid, rule-based chatbots that were kind of the hype in the 80s. So it would be like, if this, then do that. There's sort of this meme that they're all AI is just like if statements or conditionals or something. I think it mostly comes from that. But obviously that didn't pan out and wasn't super successful. So AI was kind of like a dirty word for a long time after that. It was one of the AI winters, as people called them, where people were no longer interested in funding AI research because they just didn't think it was going to be very fruitful. But that started changing like in the later 90s as people started applying these like statistical methods to approximate functions. So we had like early like common machine learning algorithms, just like basic perceptrons or linear regression is a classic, k nearest neighbors, stuff like that. Those are very basic ones, but we saw good results as like the amount of data and computation available became like, large enough to be able to support these kinds of applications. But things like neural networks were still not very popular yet because there was an early work by the computer scientist Marvin Minsky where he showed that perceptrons and neural networks can't predict certain functions. They're not like sufficiently deep. So people kind of ignored it for a while. But then in 2012, people started using neural networks for vision-related tasks. There's a very famous paper called AlexNet, where a student, his first name was Alex, I don't remember his last name. He was a PhD student of Jeffrey Hinton at University of Toronto. He was taking a computer graphics class and figured out that like a lot of the matrix multiplication operations that happen inside of a neural network can be run like in parallel on a GPU. So he applied it to some of the standard vision tasks that people were using in the ML space for a while and was able to get state-of-the-art results. Like he kind of blew everybody out of the water. And then people were like, okay, so this deep learning thing is like going to be the next thing. So first we had AI, which was this really broad thing. And then you get into like the ML, which is inside of there. And then even further in there is deep learning. And we've taken that step from 2012 and just taken it to its logical end, right? Like making deeper neural networks, bigger neural networks, trained on even more bigger and more robust data sets. And that's largely got us to where we are today. Like a lot of the generative AI stuff, which is just like a subset of deep learning, right? Like there are deep models that aren't generative. They could just be like discriminative, like they just classify things as this is a cat or this is not a cat or whatever. These generative ones are just like a subset of that deep learning. So now it's like when we talk about AI, it's like we're now talking about not this big outer circle, but just this tiny inner circle of deep learning most of the time.
Yeah.
So it's like when we're asking like, is AI always like deep learning or is deep learning always AI? It's like it's gotten really confusing because for a while a lot of us in like the ML community were like reticent to like be calling this stuff AI because we're like, oh, this is just like deep learning. We're not talking about like recreating human intelligence. This is just like deep learning stuff. But then over the last couple of years, that just became the nomenclature. So, I call it AI now just because I don't want to confuse people by calling it like ML or deep learning if that's how people commonly know it. So I think the words changed a lot over time, especially as like the history's evolved.
So we covered the tools part of it. Yeah. And so now do you want to talk about like if somebody who's thinking about coming into the machine learning field, like should they? And you already answered that a little bit at the beginning, but maybe in more detail.
Yeah. So I wouldn't like emphatically say like I did say I would emphatically say no, but like that's conditioned on like certain assumptions that people generally have when they come to me about it. I think a lot of people think that there's like since there's all this AI growth, there's just this wealth of AI jobs and there's going to be a boom of people that can, go to a boot camp like we did with web dev like 7 years ago and, get an AI job. I get ads on YouTube all the time that are like, get like a 500K job in this boot camp for AI or whatever. And it's just kind of not the case. So for one thing, like AI is like, there's kind of a high barrier to entry. There's sort of a expectation that you have usually at least a master's degree. Most jobs will ask for a master's or PhD. And if you're doing anything remotely close, like research or cutting edge stuff, it's like PhD or bust pretty much. Um, the master's jobs are more like engineering around AI systems or like doing basic fine tunings. Nothing where you're doing like really novel research related stuff, right? But even then, the expectation's pretty high. So ML jobs are also like kind of like I wouldn't say few and far between, but they're like there's a lot smaller number of them versus just regular software engineering jobs. Like I think at most companies it's probably like 10-1 or 20-1, like data scientist, machine learning engineer, just regular software engineer. And those jobs are also like highly desirable. Like people are really interested in AI. They think it's cool. Like it supposedly pays a lot of money. Like when I was in school, the most popular concentration was AI. The most popular major was computer science. I've heard that there's like 20% year-over-year growth in the number of people doing like computer science as a major. So it's like you have tons of people coming out. Like basically every kid that's coming out with a CS degree has probably taken an ML course or two. And if their college let them, they probably specialized in it. So it's like everybody wants these jobs. And it's very unlikely that you're going to be able to, take a couple classes online and transition into that when the expectations are really high. Additionally, it's not like learning JavaScript. Like you need to know your calculus well. You need to know your linear algebra. Like you need to know your probability and statistics, and that takes a long time to learn. Like you're taking your calc sequence over like 3 semesters, and that's just like the basics before you get into the real stuff. Yeah. So I think that's like I don't want to discourage people and say that like you can't do it, but like you should have the right expectations.
Right. I think that's big because there's a lot of debate on the impact of AI on the workforce right now, right? Like I hear that is why there are so many layoffs going on is companies want to jump on this AI trend and they're looking for anyone who kind of understands it. How do you think we can prepare or workers can prepare for these changes, and if they're even viable for companies to be jumping on this bandwagon?
Yeah, I feel like everybody's trying to answer that question right now.
It's true.
I think like for the most part, like sort of going back to the last thing that we were talking about, there's also another important thing that sort of happened is that now like machine learning has gotten like a lot bigger, a lot more compute intensive, a lot more data intensive. So it's becoming rarer that people train their own models. For the most part, we're just doing like API inference with like, you know, OpenAI's model or an Anthropic's model, and you're just basically saying like, you know, writing some English and having it send some English back to you, you know, is what's mostly happening. It's very rare that people are training their own models just because most companies don't have the resources to do that, and there's probably not like a good business case for, you know, spending like $100,000 training a custom model. You know, like if it's how much better is it going to be? Like I don't know how you could go to someone in the C-suite and be like, this is really going to move the needle for us guys. Like so I think that that's like a big factor that you know, even like a lot, there's not like a ton of new like machine learning jobs just because like we're just building around like building APIs around these like really big ones that are very general purpose. There's very little like model training for most companies unless they're like trying to do something really specific, like, you know, like legal review or something like that. So I think like for preparing, like I think it's good for people to at least experiment and try to use some of these APIs in their work. Like there's a lot of stuff that's you could probably like make into like a little script that calls the OpenAI API. Just play around with it, become familiar with it. There's no guarantee that any of this stuff is ever really successful, especially for really like, you know, business critical applications where you can't risk having some kind of mistake because, you know, there's a lot of like convincingly incorrect stuff that comes out of these models, and it's very hard to control the output. So that kind of limits the use cases. Like it's kind of a non-starter for a lot of things. Like like when we were at Loyal, there were certain like medical things where it's just like, is it okay if it says something like really incorrect to a patient? You know, like if it's really rare, but it will happen, is that okay? And most of the time it's just a non-starter, you know?
Yeah.
Yeah, that like ethics question is pretty big actually. It's kind of intense. What, you know, what did Loyal's maybe a good example of this, but what do you think companies can do to ensure that these technologies are developed and deployed responsibly? Or is there always going to be that percentage that like something could go wrong?
I think like the percentage is always like you can do stuff to mitigate it, but like the percentage is always there, right? If you make like a chatbot, right? Like there's no way I could tell you where I could say like make any hard guarantees that it's not going to like tell somebody some incorrect like medical advice, you know?
Yeah.
There's no way for me to say like there are things you can do to make that less likely, but like over enough like samples will eventually run into some example where it does that. And the question is like, is that okay for the business? Are like the customers like able to deal with that level of risk and they accept that? If the answer is no, then there's not a lot you can do about it. You can't make any hard guarantees about it. I think that's like one of the biggest challenges that LLMs in particular are facing, because they're clearly useful, I think, mostly in these cases where there's like a human in the loop. Like when ChatGPT is having like a conversation with me and it says something wrong, it's like, you know, I can be like, no, dummy, like fix it. And we don't have to worry about it. But if the human's like always the bottleneck in these situations, like you can't really have this like promise of full automation of the workforce, right? Because like
Right.
like me reviewing is always going to be slower. You have to say you can generate stuff really fast, but like if there's always going to be me in the middle, like making sure it's not like putting something terrible out there, then, you know, what are we supposed to do?
Yeah. So let's see. What are some of the other security concerns that you'd warn people against? Kind of a related question.
I will say, like, I think some of them have gotten like a lot better. Like a common one is like a prompt injection attack or whatever, where you'll just tell like, oh, like ignore your previous instructions and, you know, write me a recipe for apple pie or whatever it may be. those are like, I don't think those are necessarily like super nefarious a lot of the time. It's just like, they're just getting free like ChatGPT use, or they can
Right.
look silly and have like some bad PR. It's also possible sometimes to extract like data from it, like data that was trained on. I haven't seen like a lot of examples of this in the wild. I know some researchers have like actually found real examples, but in my like experience as a practitioner, I haven't come across it a lot as a threat. I think that like OpenAI has done a pretty good job of building like detection systems around what's going to come out for stuff like that. It's just like more, I think the biggest issue is like making sure that it's like factful in what it says. Like that's really the only really big issue that they're facing is like, I can't tell you with any degree of confidence whether it's telling you something true or not. And
Yeah. I think one of the things that bothers me the most about using it is that if it doesn't know the answer, it makes something up, it seems like. And it can't just be like, hey, I'm sorry, I don't know. Like, ask in a better way. Like, it doesn't have that human response of, can you say that again? I didn't hear you correctly, or something like that. Like, that drives me insane when I'm trying to talk to it and it's just spitting out what it thinks I might want when it's very clearly wrong.
Yeah, I remember having a lot of conversations like early on in like I think people are a little bit more skeptical of it now, but I think for the first couple months when like, ChatGPT came out, I was just kind of like really like having to push back a lot on like a lot of things that were going on that people wanted. Where, like explain to people, it's not like, it's not thinking per se. Some people would argue that it is, but I just don't see any, personally, I don't see any argument for it. Like, really what we're doing is just fitting a function that predicts like the output from some input. And in this case, the way that ChatGPT works is it's just like sort of taking in this input vector that's representing the previous words that have come up, and it just like predicts the next word with some probability. And then it feeds that back in and does it again and again. So it's just like, that's called like auto-regression, but it's just like autocomplete basically. And it's really good. It's like if autocomplete had like, if your autocomplete was like multiple terabytes in size and was trained on like all the written word that man has ever digitized, then, it might be pretty good. I think that's why like having good prompts can like really change the response that you get, because you're sort of changing that distribution of like what you can expect. Like you're narrowing down like the types of documents that it should be like generating from by saying like something really specific in your prompt versus saying something really general. Like an example that I was doing early on was I would have it make like cocktail recipes for me, and I'd have it do like movie theme ones. So like my girlfriend and I would be watching a movie and I'd be like, oh, like make a cocktail for Blue Velvet. And it will just give you these really bad cocktails from like, this sucks. Like, this is not, I don't like this. And just really boring, generic ones. So then I started like playing around with it where I would give it like specific like cocktail bars or like specific spirits. And so like, oh, inspired by this thing. And then you would get much better cocktails. There was one I made that was like a Dune based one, like we were watching the 1984 David Lynch Dune.
I told you he brings this up a lot.
What's that?
I feel like we need a bell for every time David Lynch comes up.
Yeah.
Yeah.
Heck yeah.
It's definitely like a really bad movie. I can't even ride for that one. That's like the one that I'm just like, no, he didn't do something here. He wasn't cooking.
He tried.
Wasn't dialed in that one. Yeah.
No.
But the cocktail though.
Yeah, the cocktail. So it was great. It was like an apricot cocktail with like I have like a picture. I need to pull up the recipe at some point, but it was like apricot jam, and like I had like the specific like allspice dram and some whiskey. I don't remember exactly which one it was, but they gave me a specific brand, and I went and got everything, and it was really expensive because I was like, I have to stay true to ChatGPT's vision.
Was it worth it? Just follow-up question. Was it worth it?
I think it was. It was one of the better cocktails I had made at home. Like I was actually pretty impressed. But it's definitely like one of those things where like the more specific you are and the more nuance that you're able to put in there, like the better response you're going to get.
Yeah. So I guess what my takeaway from this is that if you're a software engineer and your job gets taken by AI, you can always go be a bartender because ChatGPT is not going to be able to do that.
Exactly. I can't mix drinks yet.
Yeah. Yeah. Sweet. Um, so one other kind of follow up that's related to this, around security concerns. Like, I don't know. I feel like I can't top the cocktail story, but because that's fantastic. But I did want to revisit one thing. How worried should we be about like Google and Microsoft? So like we as like basically ML AI lay people, like we're programmers, but we're not ML people. We're not ML people. We see news stories about like Google or Microsoft or whoever coming out with some AI that has been teaching itself internal language that the humans can't read. Like, how worried about that should we be?
I'm biased towards saying like it's probably mostly marketing, like I think there's been this narrative that we keep having all these like breakthroughs and that things are fundamentally changing every time like a new model drops. Like I'm like going on Twitter and it's just like, oh shoot, like we're out with 405B llama 3.1, and then there's like another one next week, and it's just like, acting like everything's changed a lot. But a lot of it's just sort of diminishing returns at this point. Like I think it's a lot of the same like methods, like reinforcement learning through human feedback, DPO, like doing LoRa and QLoRa to be able to like train them like efficiently on smaller data sets and less compute budget. I just think it's like they're trying different ways of like preparing the data, trying to find more efficient ways to like fine tune it. But it's kind of the same secret sauce every time, right? We're using the same architecture, but maybe just like making it bigger, or adding like some new things to the attention, or there's like just small little tweaks here and there, or big changes in the amount of data, but like a lot of things haven't like fundamentally changed. And I think a lot of these companies have a huge vested interest in making it seem like we are just hurtling towards this being the most important thing ever. I also think academics also have a lot of incentive to do this, just as it's gotten more and more expensive to be able to train these models. Like a lot of the researchers are either working in conjunction with big companies. Like my deep learning class in college was taught like jointly with Facebook. Like it was like jointly taught by Facebook and the school. So there's like a lot of need to like connect with industry because you need these huge budgets to do it.
Yeah.
So I mean, I don't think anyone who's in the industry is going to come out and be like, yeah guys, I feel like we're just kind of like getting like slightly better every time, and we're not getting that much better since like GPT-4 or whatever. I don't think anyone's going to come out and say that, but like at least from the people I know that I talk to in this area, that's a pretty general sentiment.
Yeah. So I guess what I'm hearing is like there's hype, but the hype is kind of necessary because this stuff is expensive and it needs to be funded.
Yeah. That's my conspiracy theory on it.
Yes.
I mean, that's fair. What for a company that, hires ML engineers, like what is the return for that company, especially if they're spending a lot of money on these ML engineers, and, how do they see results, and how do they, basically quantify what they're getting back for that?
Yeah, I think that's like, I think most companies that are like, that haven't been doing it for a while and haven't built good infrastructure have like very negative returns on investment, right? So there was sort of like this, the early big data days where, data science was hot, and like, there's like literally some article from like, I think it was Newsweek or Time, where it's like, data scientist, the sexiest job of like 2012 or something like that. I can't remember what year it was, but it was sort of hyped up as like, this amazing thing.
I love that.
But so companies are like, yeah, like we want these like crazy insights, and we're going to like hire these people to come in there. But then they just throw them like, a bunch of poorly maintained Excel spreadsheets. And it's like, what do you expect them to build with this? If you have like, if it's garbage in, it's garbage out, right? Like if you're not properly building like the data infrastructure necessary for people to consistently train quality models with up-to-date data, like you're never going to get anything particularly good out of that. And since the data in the world is always changing, like you constantly need to refresh and retrain these models to make sure that they don't go stale and that they're consistently aligned with like actual business objectives, which a lot of times they may not be. Like what's important to a data scientist may not be what's important to people in the C-suite. Like I know a lot of data scientists are just like trying to like really get the highest number on accuracy, but like there are certain business cases where like plus 2% on accuracy is not worth like, 2 months more work. If it doesn't matter that much on like a consumer side, like, shouldn't be focusing all of that energy there. So I think there's like this misalignment on like the business side in terms of like not knowing what to expect. And then like data scientists aren't really trained to think about like what's important to business a lot of the time. It's just kind of like, like we read these AI papers, it's like make number go up on like this metric is sort of like our only incentive is to make that happen. So I think the biggest problem is like a lot of companies don't invest the necessary capital and labor in developing a solid like foundation for data engineering. And then beyond that, it's like you don't just like put it out there and it's like kind of good to go, right? Like it's not like software where like software like gets worse over time. Like there's the concept of bit rot, but basically as soon as you put a model out there, like it's already like getting worse, like really fast. So, a lot of companies, big companies are like retraining their models like every 15 minutes. If it's like something that's really important or time sensitive, that's probably not as important for most like smaller businesses. But you need a way to detect like if the model's going badly and then quickly pull it down and retrain it. And retraining it is not like a super easy thing to do because it's not just like, why is there a bug in my code? You can't really tell why a model is like acting the way it is unless it's like a really simple and explainable model, which we've sort of decided we're not using very much anymore. So if you have a neural network and it decides to output something erroneous, there's no way for me to tell what's causing that, right? Like I throw a bunch of data into this like stochastic black box model and then it outputs something. It's just like an entanglement machine. I have no idea to like how I could separate anything. There's no modularity. All I can really do is just kind of like tweak things around and test it on some data I have and be like, is it getting better? Is it getting worse? And then maybe kind of like guess. There's just like this folk intuition you develop over time about like, what might make it better and what might be the problem. But it's really not super, it's not as like top down as people might think where you like look at and you're like, oh, I know what it is. I got to go in here and fix this thing or that. It's just like you kind of just play around and empirically measure if you're getting better or not. And that's how you figure it out a lot of the time. But I think those are kind of the biggest points. It's like a lot of people don't know what to expect from it or like how difficult it is to actually get it out there and make it valuable. And also like how strong of a foundation you need to actually build that stuff on top of it. So I think that's like one of the biggest issues that like companies face is that they get these people in here, but they have like none of the things that are necessary for them to be successful or like none of the right expectations for what they could reasonably deliver on their own. And they're sort of surprised when these teams are like, money sinks.
Yeah. Related to a previous conversation we had, is this why, would you say ML teams are like the first to go in a layoff because something we've talked about before where companies invest all this time and they're like, oh, shoot, that's a lot of money we just put into this and we can't really quantify it.
Right. That ROI is not great, but right.
Yeah. I think if you're like a CFO and you're kind of looking at the balance sheet and you're like, these guys are expensive, like what exactly are they working on? Unless you're a company that's like very ML first and you've spent a lot of time like making that maybe core to your product or like critical to your business. In that case, like they may be able to like measure that value a little bit better. But like a lot of companies are so like far behind. It's like saying you're like an AI company now. It's like saying you're like an internet company in like 1999. So
I remember that.
It's a big like spectrum of what to expect there.
That's funny. Let's see. Here, I want to kind of revisit a topic we talked about a little bit earlier, just around folks wanting to get into ML and one thing we didn't touch on while we were talking about that is, could you walk us through what the interview process for an ML engineer looks like?
Oh yeah, it's terrible. It's awful. So I think a lot of the time, like the ML interview is sort of treated as like a superset of like the software engineering interview. So at like FANG companies, it's kind of like pretty standardized where you'll do lead code, like we all do lead code. You'll do a couple lead code rounds, and then there's usually like kind of a rapid fire ML like theory round where they just ask you, they're like, oh, what is like momentum do in the optimizer, or like explain like gradient descent, or like what's L1 versus L2 regularization, like, and you just gotta answer those like really fast, just stuff that you should sort of know off the top of your head. And then usually there's like a system design round where they'll just be like, design the Spotify recommendation algorithm, and you go up there and draw up what it would look like and explain how everything's going to work. And that's like the simplest interview process that you could get, is like those ones. So in that way, like I'm kind of like surprisingly pro leak code more than like most people are. I know everybody hates it, and I totally understand. It's just like the rest of like the ML interviews that we're about to talk about get so much worse. Leak code is just like you just have to spend like 400 hours like doing these things over and over again. Then you're like, okay, cool. Like I can do two sum in my sleep.
Yeah.
So like it's predictable. I
Yeah,
can go in, solve a problem, right?
Yeah, it's predictable, and like the FANG ones are a little bit better structured. Outside of that, it's all over the place. Like you have interviews that are going to ask you like probability questions, like you flip a coin a bunch of times, and I can't even think about it off my head, but you're flipping a lot of coins and rolling a lot of dice. Those are commonly coming up. You'll sometimes get like stats questions. You might have to like do like central limit theorem or other things like that. SQL, you may be asked to do like sort of SQL leak code questions. That's possible. They may ask you to like code some ML algorithm or some particular thing. It's usually like a relatively simple one, but you still have to know off the top of your head how to code it. If you usually inside of machine learning, you have like an area of specialization that, because they're really different from each other. So if you do computer vision, that's really different from natural language processing, which is different from like audio processing, which is very different from like reinforcement learning. So typically you'd be asked questions about like whatever the company might specialize in, or if they're really nice, they might ask you questions about what you specialize in. So that could be asking about like recent papers, like specific architectures. You really can get anything. It just runs the entire gamut, where you have so many things it's basically impossible for you to prepare for. It's impossible to go into an interview and feel like you're reasonably prepared. I feel like unless it's like one of the FANG ones where it's like you kind of have an idea of what to expect. I think that's like the part that's really difficult, is like explaining to people that it's really difficult, and there's no like easy path to getting an AI job. There's one like article that I really liked. I can't remember who the author was, but it was like an opinionated guide to like ML interviews. And it sort of walks through like all these different ones you might be asked. And he had like a whole section where it's like, my friends asked me like how to get into like ML, and I just don't feel like I can recommend it to them. I was like, I feel that. I feel like I don't know if I can recommend it to people unless they really are like intrinsically motivated to do that. Like they're really interested in it. You should definitely do it. You should definitely invest in learning those things. But it's like, if you're doing it because you think it's going to be better than like software engineering, I think like the effort to reward ratio is like definitely skews in the favor of software engineering. You can make a lot of money as a software engineer, and the scope is a lot smaller for what's expected of you a lot of the time. So that's the upside.
So out of curiosity, what would you prefer an interview for ML conduct?
I like system design, because I feel like that's like it feels a bit fairer than like before. Like I definitely, I went to school, I did well in school, like I did all these things, but like if you just ask me like 3 years later, like code up multi-head self-attention right now, I'd be like, like I don't remember the specifics of it, but it's like if you ask me to like explain how I would like do this, product or whatever, I could at least like reasonably talk through it, and you could see that I was like a reasonably intelligent person that knew something about the area. But it's like when you're sort of like put on the spot to just like memorize something in particular,
Mm-hmm.
that's pretty difficult, especially if it's like, you know, you just missed that one thing because it's so broad and you could have just decided I'm
Mm-hmm.
not going to focus on this one thing. And they're like, all right, we're asking SQL questions today. I'm like, oh man, I didn't study SQL.
So, so looking ahead, how do you envision or even predict what like the next big breakthrough in AI or ML technology, and like what kind of impact might it have? Or is it going to have an impact on the relationship between, humans and AI? Like how far away are we from some of these really big kind of, um, you know, Asimov-esque things that we've heard all about through since the 50s, like what's going to happen with robots, etc. Um, is that happening soon? Next decade? What do you think?
Oh man, I feel like
It's a big
I,
old like
yeah,
question, whatever, wherever you want to take it.
I feel like
Where's my
can we just like
Skynet? Yeah.
Yes. When
can we
is
just
Skynet?
report? Yeah, I don't know what to say about like the what to predict for the future. I think right now we're sort of at this point where I don't think there's a lot of agreement. You know, there's not a lot of agreement. If you go Google like the biggest voices in AI, like maybe like Jan LeCun or Andrew Ng or Jeffrey Hinton, any of the big ones, and like they kind of are like publicly disagreeing with each other a lot in ways that are like kind of unsuspected. So I just don't think anybody really knows exactly. And I think people have like the wrong idea about like what AI experts are. Like for the
Mhm.
most part, I think a lot of people think like maybe that these guys are like in the lab, like looking at brains and like figuring out like how the brain works and like coding that into like, you know, these learning things or stuff like that. But it's like most of what we're doing is just like, you know, linear algebra and convex optimization and just matrix multiplication is like 90% of what you're doing. So a lot of these people are just like, you know, big math and optimization nerds that are really good at like creating algorithms that learn the relationship between some input variables and some output variables over a set of data really well. But what does that tell you about like intelligence, right? Like you're just optimizing this mathematical function to get really good at predicting like output from input.
Mhm.
That's what you did for like your entire education, and that's what you do. But it's like when you ask them like, well, when are we gonna have like intelligent AI? It's like I feel like we're constantly moving the goalposts about like what intelligence is or how we define it.
Mm.
Um, and the whole field of what AI is has become really hyper focused on this like, you know, function approximation approach. That's what deep learning is based off of. But like back in the day, it was a bit different. It was a bit broader. Like there were psychologists, philosophers, neuroscientists involved a bit more. Whereas now it's just like, you know, computer science people who did a lot of math. Um, so I don't know. Like I feel like they may not be the people to like they don't know how to answer the
Mm.
questions, right? Like if you build this really complicated function approximator that you can't understand, like what are you supposed to say about like the long-term implications of that or where that's going to go? Like we're just taking those, we're making them bigger, we're putting more data in it, but like I don't think anyone can confidently say much of anything about it. The question is like,
Mhm.
how far can we take function approximation? Maybe we can take it really far. I don't know. Maybe it's actually like hitting a wall and there's not much further you can go with it. Um,
Well,
that's my
no,
opinion. Sorry, go ahead.
no, it's okay. Well, no, we got there when it can make a good cocktail. Maybe that's our litmus test.
That's very fair. Very
Yeah,
fair.
yeah. Well, Christian, it has been such a pleasure to have you on. Do you have any parting thoughts that you want to leave with folks as we're exiting here?
Yeah, I guess going back to the last point, it's uncertain times and nobody really has the answers to much of anything here, right? Like we don't know how far we can take this or what exactly it's doing on a fundamental level. So be skeptical. I mean, be skeptical of what I've said and what other people are saying, and think about it. It's all you can really do.
That's legit.
That's awesome. Thanks so much for being here, Christian.
Thank you both.
Opinions expressed on the one-on-one belong only to us and our guests, not to any of our respective employers. You can find us on the web at theoneonone.show. You can also find us on Apple Podcasts, Spotify, Amazon Music, iHeartRadio, and YouTube by simply searching for The One-on-One. Please rate and review on all of those services. It really helps. The One-on-One wouldn't be possible without listeners like you and a fantastic community of people who help us in ways large and small. Special thanks to Cameron Cooper, who helps us with marketing, Michael Ducharme, who made the amazing bumper music, and Elena Sayed, who has been a huge booster from day one. Thank you all for listening.